Welcome to Class Time Mathematics. I am Tamika Lodge Fenton.
And I am Camille Johnson Burrell. Let's begin. All right, so today we're going to be looking at multiple choice questions featuring measurement, statistics, and probability.
Yes.
So let's go.
What is measurement?
Measurement. Oh, I guess it's when you measure something.
All right.
Maybe you put some numerical values to some quantity.
There you go.
Somewhere along that line.
Sounds much better. Numerical value, quantity. All right, let's define it. So measurement means to compare to a fixed standard value. All right. What does that mean? A fixed standard value, like you have to have some designated measure of something to compare it to.
Yes.
All right. It also means to measure something is to give a number, as you said, to some property of the thing. And measurement can be written using many different units.
We're going to take a look at some of that type of measurement that we're
Sure.
talking about. We're going to take a look here. So here we have measure and length. So length is a measure of how high, long, or wide something is. Still measurement. That's length. Now we're looking at mass. So here we're looking at the mass of the books right here.
That's a
And we
beam
have a
ballast right
CD
there.
right there as well, yes, and our scale right there.
That's
too.
a heavy CD though, because it looks like it balanced. That's a metal CD.
Well, maybe. Could be. Could be. And here we have our time. So
Yes.
all these are linked to measurement.
So these
for
are a
length,
few things
mass.
we can measure.
Yes.
Okay.
Now we're taking a look at
Statistics.
statistics, right? And this is the study of the collection, analysis, interpretation, presentation, and organization of data. What was that? All right. In other words, it is a mathematical discipline to collect, analyze, and summarize data. That's it. So when you talk about statistics, we're looking at graphs, we're looking at data, all of those
So
things,
you
how we
have to-
collect, how we present it, how we discuss our findings, all that is entailed in statistics.
Makes sense.
Yes. And lastly, remember we had outlined three
What?
headings,
Yes.
measurements, statistics. Now we're
And
looking at probability.
So probability is simple. It's simply how likely something is to happen.
Let's take a look here.
So here we have a probability line. So we have starting from 0 to 1. At 0, you'd call that event impossible.
Impossible.
So it is impossible for me to be 20 feet tall.
Well, that is true.
So that's a probability of 0.
Yes,
All
it
right
is.
then. What about unlikely to happen?
It's unlikely that rain may fall because the sun is shining brightly.
It's
this
unlikely.
morning. Yes,
Not that it can happen, but it's unlikely.
But it's unlikely based on what is happening, so it's unlikely.
Okay. Equally likely. So this is an even chance.
Yes.
So when a woman is pregnant, it's either a girl or a boy.
Yes.
It's an even chance, 50-50. Then you have likely to happen. It's likely that I'm going to eat today.
Yes, it is very likely.
It's very likely. And certain, we all must die. Certain, 1%. A 1. 100% it would be, right. Okay, so it would be 1. The probability of death is 1. So probability is always between 0 and 1. You can represent probability as a fraction, decimal, or percentage.
Right. So we really looked at measurement.
So we're going to spend some time
On
on
measurement. We looked at statistics.
Yes.
And we looked at, what's the last one again?
Probability.
So we're going to take a look, firstly, at some measurement multiple choice questions. So let's look at the first one. 3 lights, red, yellow, and green, flash at intervals of 4, 6, and 10 seconds, respectively. They all started flashing together at the same time. What is the next time they will flash together? And remember,
right.
we're looking at multiple choice questions, so let's have a look at our
options.
first. So here are
Right.
our options, and we have our red light, yellow light, and green light.
So first, we have to pretty much understand what the question is saying to us and what the question is asking us to answer. So there are 3 different lights flashing. The red light is flashing every 4 seconds.
Yes.
The yellow light is flashing every 6 seconds. And the green light is flashing every 10 seconds. All right, that's one part. All right, then they ask, what is the next time they will flash together? So we're trying to figure out when these lights are flashing, what time will have to pass, because the options are in seconds. How many seconds later will they all be flashing?
At the same time.
All right.
They must flash together.
All right, so
How
we
would
can
you do
just
this
run
then?
through it ahead roughly. The red light will flash 4, 8,
So the first time it will flash, it will be at 4 seconds. All right.
Then you add 4 to that, which would
Okay.
be
8 seconds.
The next 4 would take it to 12,
seconds.
and then 16. And we could
16
pretty
seconds
much
continuing.
list this out.
All right.
Then the yellow, we're talking about 6, then 12, and then 18, right? So we keep on adding 6 to find out then when the light is going to
Flash.
I'm going to have to put that somewhere because that's
Yeah,
a lot
but-
of information to hold in my head.
But you only talk about the red, the yellow.
So now the green light. So every 10 seconds, which is easy. So it's 10, 20, 30, 40, 50, 60. It's going to be flashing.
Right.
So we see it there. It will flash at the 20. It will flash at the 40. It will flash at the 60. And it's clearly going to flash at the 242.
But guess what? They asked for the next time they will flash together.
Oh, so we need for all of those times to match up.
Yes, we do need that. So guess what? We can, just as how you are listing it, we can list it in a table form.
Oh,
So we
here
have
we
our
go.
red light or yellow light, and remember we're looking at time in seconds here.
Right.
Our green light. So we would have started listing out from the very first time
Right.
all lights would have started flashing. So we have our red light for 4 seconds, our
Yellow.
yellow light starting at 6, and our green light starting
10
at
seconds.
10 seconds. So if we take a look, we realize, as you rightly said, for a red light, we would have been adding 4 seconds
Yes.
on each flash. For our yellow light, again, we would be adding 6 seconds each
Every
time
time
it
it's gonna
flashes.
flash, right.
And for the green light, 10 seconds each time it flashes. So, all right, this is, can we look here and see a common time for all 3 lights right here, just looking at our table here?
You can see it for 2 of them. Like, for instance, you can see that the red light will flash 40 and the green light will flash at 40 as well, but the yellow light is not flashing at 40.
Good, and they did ask us for all, three lights.
Okay.
Right, so we
So
know
I have
that
to go look at
40 is
some more
possible.
numbers.
And if we take another look, we realize 20 is also possible, but it's not for all,
three, just for the red and the green.
Great, all right, but so let's continue listing our time.
Sure.
So here we now have again a red light, yellow light, green. And remember, we would have ended before on our
Right.
40, continuing, and now we're starting with 44. So we have 44 up to 64. So let's take a look here. Anything looks...
I remember
Close
that
by.
the green light was flash on 60 now because I was telling I was counting by 10. So I'm sure the green light is going to flash on 60.
All right.
And the red light is also flashing on 60.
All right, but what about the yellow light?
It's every 6 seconds, right?
Yes.
So 66 is here. So if I take off 6 seconds, it would have flashed at 62.
All right, let's do a little table, a smaller table.
Yeah, because
here we
let
go.
me take out a piece and see. Yeah, man.
So
they're all at 60.
So
They will all flash at 60.
So we're red,
60,
60,
yellow,
yellow
60,
60,
Green,
and our
60.
green 60. And we're all, so all 3 lights will definitely flash at 60 seconds.
No. What did we just look at though? Because we were looking at 4 and we were counting, we were adding 4 each time. These are multiples of 4.
Yes.
And then we were adding 6 each time. Those are multiples of 6. And the same for the 10. They're multiples of 10.
That's right.
So you definitely have to access this question. You're going to have to look at the multiple of all 3 numbers and see where they have a common multiple. And in this case, the lowest common multiple, which would be 60.
You're right,
So it's 60
because we
seconds.
could have had 240
Most
if we
definitely.
had continued.
Yes.
But again, remember they said the next time they will flash together, which would have been after the first time they would have
Right.
flashed together. So here we have 60 seconds.
So I hope they remember the term, everybody should know LCM, which is the lowest common multiple. So this question, you definitely have to look at the LCM
Yes.
to access the question, because you wouldn't be doing that table for the entire time. It's a multiple choice question.
That's right. Let's take a look at another one. So how many grams are in 2 kilograms? Pretty straightforward,
I
right?
think so too.
Pretty straightforward. And why is it pretty straightforward? Because we already know that 1,000 grams is equal to 1 kilogram.
1 kilogram. Why do I keep on saying gram?
So if 1,000 grams is equivalent to 1 kilogram, then 2,000 grams
Will give you.
will be 2 kilograms.
Right.
So this one was pretty simple. We
So
just need to use
standard information.
Yes, so we already know that our 1,000 grams would have been 1 kilogram. So we know that we're using that as our benchmark.
Right.
So in looking at this, we have 2 kilograms and we look at our answers here. It definitely would have been our
C.
C.
So there
2,000
are some
grams.
information that you have to go to the exam with. You have to know this. You can't calculate this. You can't calculate how many grams to a kilogram. You have to know this information. So guys, remember to pay attention to those information when you're looking at measurement topics. Pay attention to the conversion of grams to kilograms, kilometers, meters, all of those things you have to go to the exam with.
And bearing in mind too that you cannot take a calculator to the exam
multiple
with
choice.
Yes. So you can't use a multiple choice. Well, you can't use a calculator with the multiple choice
Right.
exam, none whatsoever.
Right.
So you have to go with your information. You already know it. You
And
know the
simple.
content, and you just now need to apply it.
Simple operation skills, you have to have that.
All right. So
Okay.
here goes.
A rectangular tank is 100 centimeters long, 30 centimeters wide, and 12 centimeters deep. The volume of liquid it will hold is, and you would have had your options, A being 3.6 liters, 36 liters, 360 liters, 3,600 liters. No, it's a volume question. What we know about volume?
Three-dimensional.
Great. Volume requires us to have 3 dimensions, which was given in the question.
Yes.
100 centimeter long, the depth of it, the width of it is 30 centimeters, and the depth of it is 12 centimeters. So pretty much it's calculation. So, but let's see what the calculation will give us, because now we're going to multiply 100 centimeters by 30 and then by 12. But the options you were given were in liters.
Right. Good. So
now
what do we know?
We worked it out, So you work out the volume. It's now 36,000 cubic centimeters.
And this is why it's important for us to know some of these facts, because
you
we
need to
should
understand
know
that
that 1 cubic centimeters is equivalent to 1 milliliters.
There you go.
And we should also know, looking at both of these now, because if 1 is equal to 1,
If it's a 1 to 1, we can
here we're
simply
seeing
change it.
1,000 cubic centimeters is equivalent to 1,000 milliliters. And guess what? We should know that 1,000 milliliters is the same as 1 liter.
There you go.
So here goes, 1,000 cubic centimeters is
also equal to
1 liter.
So now we can convert our cubic centimeters to liters to match the options we would have had in the multiple choice.
Which is how we got this. So we would have divided our 36,000 cubic centimeters by our 1,000 cubic centimeters, and we would have now arrived at 36 liters.
There you go.
So pretty much we needed to know the volume, yes, but after
So you need to
looking at
know
the volume,
the concept of volume.
yes,
And you definitely need to understand liters and cubic
centimeters. Yes. And even the links, still cubic centimeters and liters, but there's a link with milliliters.
Right. There
So
you have to
must
know how to
that.
convert.
Right.
Right. So the area of the trapezium ABCD above is, now this question could not have been more straightforward. You're finding the area of the shape that is given. And you have some options there, which it's good to pay attention just to for your guide. Now, how do you find the area? Area is that region that's covered, that covered region by the bounded shape. So we're talking about all that's in here. Great. So now I would go with, hey, I can see a triangle and I can see a rectangle. So I would just put a line here to form that perpendicular height of the triangle here. And I know that this is 3. So if I put it right here, this is 2.
All right.
So I could find the area of this triangle and then add it to the area of the rectangle.
Okay.
So if it's 3 multiplied by 2 would give me 6 square centimeter over there. And then this is 2. The perpendicular height is also 2. That's half base times height. So that's half base is 2. So it's 1 times 2. That's 2 squared centimeter. So we're talking about 2 plus 6, 8 squared centimeters.
All right, pretty much.
Would be my area.
And we should already know, so in addition to that, we know it's a trapezium. So we would have known that with a trapezium, we have 2 parallel sides. So 2 sides are parallel.
Right.
So we have our AB is parallel to our DC. So when we're looking at the area of a trapezium, we're looking at half then.
Right.
The sum of the parallel sides, the lengths of the parallel sides multiplied by the perpendicular height.
Most
so we could have
definitely.
looked at it from your angle, and we can also look at it from the angle of going straight forward to find the area of
a
the
trapezium.
trapezium.
Okay.
And you would have rightly said we would have definitely arrived at the same answer, because half multiplied by 3 plus 5, all in bracket, multiplied by 2, remember our 2 here is our perpendicular height. So it would have now been half multiplied by 8 multiplied by 2. So half of 8 is 4 multiplied by 2, which gives us 8 squared centimeters.
So you can access this question by decomposing the shape into two plane shapes as the rectangle and the triangle, or if you are fully aware of the trapezium formula, just plug in the values.
Yeah, we just
And
need to plug it in.
solve.
Not hard
Not
at
at
all.
all.
And in using the formula too, we have to understand, because when you look at this, we realize that, hey, we have to know what our 2 centimeters here really represents, what DA represents. It's actually the perpendicular height. So when you would have gone over here to have no, all right, I'm going to
shape.
Yes. So when you would have decomposed your shape here, then you split up your shape, you cut it up, right? And you would have known, all right, I know 2 is here, so 2 is over there as well. Remember, I know we have CB too, so where you're going to put the 2, why would you put your 2 there? Why are you going to place it there? Because it's the perpendicular height
Of my triangle and my rectangle.
And right here, you would have gotten a right angle triangle.
Most definitely.
So you would have gotten a right angle triangle. So let's take a look at another question in measurement. What was the average speed of the train if it took the train 9 hours to travel a distance of 1,080 kilometers?
All right. So when we talk about average speed we're talking about, when we're driving on the road, although we say we're traveling at 80 kilometers per hour, we're traveling kilometers, yes we do.
Yes.
Right. Although we say we're traveling at, occasionally we'll go up to 85, drop down to 75. So on average.
Really, we do?
Yeah, of course we do.
Okay.
And sometimes it's like a little, you might see a police around there, you kind of slow down, right? So the average speed talks about, if you were to look at the entire distance, most of the time you would have been traveling 80. Or, if you want to look at it like that. But when you talk about speed, we're talking about distance over time. The distance you've traveled and the time it took to travel that distance. So we can pretty much plug in the formula here. Speed is equal to distance divided by time.
Right.
To determine the average speed.
So here goes. We know our distance, 1,080 kilometers. We know our time, 9 hours. And as you would have said, we would have divided our distance by our time to find out what's our average speed, which would have given us 120 kilometers per hour.
Right.
But guess what? In looking back at our responses, yes, we would have arrived at our answer.
Right.
But there's something key to note here. We have to ensure we look at our units.
Most definitely.
Because it could be a case where we were asked to find the same speed, yes, but in looking at our responses, we may have been given meters
per second,
meters per minute. It depends. So we
Right.
really have to take a look at what our units are here in our responses to know which angle we take it from.
Right.
Because when we would have gone ahead just now to have found 120 kilometers per hour, if we were given another unit, we would have now had to know some facts.
Yes, if we were given meters per second, we'd have to convert our kilometers to meters and our hours to seconds to give us to match the options that would have been given. So you are perfectly correct. You need to pay attention to the type of options you have as you move into your calculation.
And it also helps because in even looking to here, when we would have been dividing our 1,080 kilometers by our 9, we could have gone ahead to say, hey, there's 12, you know. So right here, looking at the answer, I can say 12 kilometers per hour is my answer. But guess what? Again, understanding how you are basically dividing here.
Right.
You would have looked to see, oh, it's not just 12. No, not at all.
Right.
And you would have worked it out to see that, hey, so you look at your distractors too because they're very good distractors here. And you look to see, all right, it's definitely B, and this is why it is definitely B.
Yeah, because A, definitely not.
Out. Can't
Right.
be. Let's look at our distance there. It's more than our distance there, so we'd have to just strike out A and looking at D. No, not
Yeah,
at
the train is
all.
not going to travel 12 kilometers per hour.
Right,
No.
based on what we're given here. So we
Right.
know it would have been between B and C.
Right.
All right, so here we have another question. So in the circle, the circumference is 20 centimeters. The length of the arc AB in centimeters is, and we're asked to find this. So again, we need to know some information. So what are the
yes.
information that we need to know?
So the word circumference is really just a unique name for the perimeter of the circle. So we're talking about the distance of that boundary for that shape, right? So if we're talking about, they gave us the circumference, it's 20 centimeters. Now, AB is a part of the circumference, so it is a fraction of the circumference. Since we already know the whole of the circumference, and we have some other information, the total angle in a circle is 360 degrees. And the arc that we're looking at, AB, is denoted by the angle 45 degrees. So I can now represent it as a part of the whole circle, circumference, which is 45 degrees of 360 degrees.
Why 360 degrees?
Because the whole angle within the circle, the total angle within the circle is 360 degrees.
All right.
So I can definitely do that. But then when I represent it and I look at my options, it's not there.
It's not
So
there.
I don't have 45 degrees over 360.
All right.
However-
But look and tell me if you can eliminate any answers before we try
Well,
to...
45
simplify.
definitely is out. D is
So
out.
D is out, all right.
And the 145,
So A is out as
is
well.
out, right.
All right, so D is out and A is out. So it's
I'm gonna
between
choose
B or C.
Right, so clearly I'm going to think about simplifying the fraction that I've just formed.
Good. So here goes. So you would have said your angle divided by your 360 multiplied by your 20 centimeters, which your angle would have been 45 degrees.
Right.
And here you have 1/8 when 45 degrees divided by
It's
360
factored.
degrees.
Right.
Yes, it's simplified. We have 1/8 multiplied by 20 centimeter, which our answer was indeed here.
Right.
B.
So again, we have to look at some information that you have to go into the exam with. The total angle within a circle, 360. That's not given. You have to know that, right? You also have to understand what the circumference is. The circumference tells you something about the circle. You have to know that. So these are some things that you have to prepare yourself when you go in and you meet these words.
And if you don't
right?
see, if you're trying to work it out and you don't see your option, try to see if you can simplify. Because in right here, when you would have tried to simplify it, you realize that, hey, my answer is there. It's really
Right.
there. It's just in a simpler form.
There
It's
you
not
go.
my exact form that I would have calculated it in, but the answer is there. So look to see if you can see the answer.
Right, and definitely as well, sometimes we go straight to working out without looking at the options. Don't work out because it doesn't require that.
Now we're at another measurement question. So
Right.
here goes. A circular hole with diameter 6 centimeters is cut out of a circular piece of card with a diameter of 12 centimeters. The area of the remaining card in squared centimeters is, and we see our options here, but they may look a little bit uncomfortable to the eyes for some of us, but these are our options here. And we have, just to help us who are visual learners, we have there on our, to the viewer's right or left, an image basically
what?
of looking at what the circular hole would be like.
Right, the rest of what is left.
Yes.
Because they took out that piece.
Yes.
Okay, great. No, so it's simply, we're looking at the options, it tells us that we don't have to do any extensive calculation because
No.
the value of pi remains. All right, so let's look at this then. So we're talking about area of the remaining card.
Yes.
So right away, you need to know what the area of a circle looks like. How do we determine the area? How do we calculate the area of a circle?
And we know it's pi r squared.
There you go.
But when we look at our question, we realize that we don't see r, which is radius,
Right, we have
in our
diameter.
question.
So we should know the relationship with a diameter and its radius. 2 radii gives you 1 diameter. Or we can say the radius is half the length of the diameter.
That's right.
Right.
So in looking at this now, so we
How
know
do we
the
go
area
about?
of the circle. Well, we know the area, how to find the area of a circle. And when we look here, we realize that we have 2 circular pieces here
Right.
taking place. A circular hole cut from a circular card.
So-
And we're given our measurements here. We're given diameter of 6 centimeters. We're also given a diameter of 12 centimeters.
A simple maths, man. They want to figure out what is left. So we're going to find the area. We're going to determine an expression for the area of the entire circle. Circular, what they call it, circular hole. The card.
The piece of card that is left, yes.
We're going to find the area of the whole thing, and then we're going to find the area of what is cut out. Then we subtract it from the bigger one, and then we get what is left.
All right, great. So in taking a look here, we know that the area of the circular hole with the diameter of 6 centimeters, and we
Using
would have
the
already
formula.
established that pi r square radius can't be 6 centimeters here, so our diameter, so our radius would have been 3 centimeters.
Great.
So here it's pi, and we have our 3, the radius in brackets, squared.
Right.
And this gives us 9
9
pi.
So 3
9
multiplied
pi,
by itself.
yes.
9. Great.
And this would have been the area of the circular hole with diameter of 6
The one that they cut
centimeters.
out.
Yes.
Oh, great. All
All
right.
right. Then now, we're now looking at the other piece with,
The
so it's still
whole
a circle, because
card.
when you cut the circular piece or the
The
smaller
rest-
one, you still have a little circular hole left there.
Right.
It still resembles the circle. So this one now has a diameter of 12 centimeters.
Right, so
And
this would have been the entire card before they cut out the whole man.
yes.
So now we're finding the entire circular card. That would be, and as you said, we're given diameter of 12 centimeters. So the radius is definitely half of 12, which is 6. And you put it into, you substitute it into the formula, and 6 multiplied by 6 gives us
36 pi. But
There you
that's
go.
it? That's our
no,
area?
man, no,
We
no,
finish?
no. They cut out piece, man. They cut out the smaller one out of the big one. So we're going to subtract it from it.
All right, so that means then that the area of the remaining part is basically the difference.
Most definitely.
Right, so it's the difference between both the areas, 36 pi minus 9 pi, which leaves us with 27 pi. So right here, it's not that you look at the, so some of us would just look and say, boy, this look hard. But come on, use what we know. So we know how to find the area.
Right.
We know that, all right, they're talking about a circular here, and that they have a diameter here. What do we know about diameter? What do we know about
Right.
radius? We do our linking there to see what's happening. And after we would have done that, we try and see, okay, where can I start? We start it, and then we take a look, and what we can do too is looking at our responses here to see if we're on the right track.
Right, because you don't want to read the question, not look at your responses, and just start working out area and calculating that you're using pi as 27 over 7, and you just start working, because a lot of times people do that, and it's not required for you to put a value for pi. First thing was even given, and normally you're given a value for pi. So if it's not given, you just look at your options.
Yes, that's right. So right here, our answer would have been B, 27 pi.
Excellent.
But let's take another look at our last measurement question for this session here. So we have the lengths of the sides of a triangle are x,
2x, and 2x, and
2x.
2x centimeters. Right.
If the perimeter is 20 centimeters, what is the value of x?
So here we are, another, again, perimeter. Another key term that you have to understand before you come in here. What does perimeter mean?
Perimeter.
We're talking about all those sides. If you were to add up all those sides, we're talking about the distance around, on the boundary of the shape, right? That entire, that total distance on the boundary of the shape. So it gave us some stuff. It says the sides of the triangle are x, 2x, and 2x.
Right.
Right? So 2x, 2x, x. I'm going to run with that. It's not drawn to scale, guys. And we know that the perimeter is 20 centimeters. So we can pretty much make a simple math sentence. So x plus 2x is going to give you 20 cm.
All right, let's see if you're there. All right, good. But what else?
Well, you know, you should know by now when you have any unknown, any algebraic terms, you can combine where possible. They're all the same. They're all x. X plus 2x give me 3x. 3x plus 2x, 5x is now equal to 20.
All right, so that's our answer. 5x
No,
is
they never
20.
asked you that.
Wasn't that
They
what
said,
they asked
what
us?
is the value of x?
Oh, so we're not finished.
No, we're not.
Okay.
So let's simplify this. Let's find the value of x by undoing that 5x there by dividing
So
by
we're going to
5
divide
throughout.
both sides by 5.
Right.
So when we divide both sides by 5, we arrive at x is equal to 4
There we go.
centimeters. So here goes. So our x here would have been 4 centimeters.
Right.
And even looking at it here, we could start eliminating to say, no, it could never be D, none whatsoever, because if x is 10, that means x would have been 10, 2x is 20,
20. And the
plus
perimeter is
20 plus, so 10 would have definitely been out. When you take a look at 8 as well, we realize that 8 is still too
16
large
and-
because
yes.
that would have been 2. When
So
we
you
add the
could
two x's, we would have arrived at 36, which is greater than 20 centimeters, because the 2x plus the 2x, which is 4x, and would have given us a value larger than the
total,
20 centimeters, the
perimeter.
perimeter here.
Right.
So we know point blank that it would have been either A
or B.
So we
Right.
know going into it, all right, this is what we're looking at. I'm looking for an answer either close to 4 or close to 5. So
And
eliminating.
after a while of doing questions like these and looking at algebraic sentences, it becomes easier. So you see x, 2x, and 2x. You are right there, 5x.
Yes.
Equated to 20. You can really and truly do it mentally.
Yes, you can.
You know? So just pay attention to the details in the question, look at your options, and try to do the question as quickly as possible. Doing it with a correct response, though.
Right. And we would have looked at measurement questions.
No, we're
So now we're
at.
going to statistics. So let's take a look at our first one. So the mean of 10 numbers is 58. If one of the numbers is 40, what is the mean of the other 9? And we have 4 possible options here, yes, but we are given some information.
Well, we know C and D out, because if the mean is for 58, how we must get 98? And, well, maybe I could get 98 and I don't know.
For the
But
mean of the other 9.
540
All right.
is way out.
All right, but 98 is still out because the mean of the other 9 could not be 98. But all right.
All right, so what does the mean tell us again?
Now we're looking at average mean, because
Right,
we have average
average
mode,
mean.
average
So it
median,
is-
average mean, so mean. All right. So we're looking at, so it's 10 numbers. So it's how evenly distributed
There
these
we
numbers
go.
are, right?
Right.
So it would have been 58. But we're given one number. We're told that one of these 10 numbers is 40. So before even doing anything, we need to figure out, we kind of need to now work backwards.
Right, okay. So we know that the mean of 10 numbers is 58. In order to calculate that mean, I would have summed all of the 10 values,
Yes.
then divided by 10. So if I just simply multiply my 58 by 10, it would give me my sum.
Now you understand why I say
Yes,
we're
ma'am.
working backward,
Oh,
because we
most
have the
definitely.
mean, so we're just going to work backwards. So right here then we can say, since the mean of the numbers is 58, then the sum
Of
is
the numbers is
580, right?
Right.
So we know that. When we look again, we realize that one of our numbers is 40.
So we can take it out.
All right, so we're going to remove our 40 then. So we're subtracting here. So it's going to be 580, subtract 40, which leaves us with 540.
540.
So now we see that D would have definitely been out completely.
But we can see where the mistake could have been made.
Yes.
Because when you reach here and you see the options without fully understanding what is being asked, you could circle D.
Yes, you could.
Because you got it somewhere. So pay attention. The mean, this could definitely not be a mean. So what we know now, 540 is now the sum of the remaining 9 numbers.
Yes.
And we're asked to find the mean of the 9 numbers.
Yes, that's right.
So we're going to definitely just divide by 9.
And when we divide by 9, we arrive at
60.
60. So now we see 98 would have definitely been out. 540 would have definitely been out. And now we're seeing that 18 is not a possible answer
Right.
either. So our answer is definitely B.
Now, if you don't understand the concept, you could subtract 40 from 58 and get 18, which would have been A, which is a good distractor.
Yes, it is.
Okay.
Yes, it is.
A store owner employs 12 clerks at $26 per day and 8 floor personnel at $17 per day. What is the mean daily wage of the 20 employees? So we're here back at mean. All right, so we have 12 clerks and they get $26 per day. So if I were to write this down, I would have $26 12 times.
All right. So let me
And
see if
then-
I can help you.
Right. So, all right, instead of writing it down 12 times, I could multiply it by 12 to give me $312. Now I have 8 floor personnel, $17 per day. So for the day, if I was to pay them, I'd have to have $17 8 times. I can multiply it.
All right.
All right, so that would be 8 times 17 gives me 136. So that's for the 2 set of workers I have. Oh, I've just taken on the store owner position. All right, so now I want to find out the mean daily wage of the 20 workers. I'm going to have to add those up. All right, so I add both totals and I get 448. Now, how many workers do I have? I have 20. The mean is sum divided by the total number of values that I would have added. So I'm dividing by 20. And there you go, $22.40.
So the mean daily wage here of the 20 employees is $22.40. We're getting on. I think we're getting on, and I think they're understanding at home as well.
I think so.
But let's go to our next question here and see what's happening.
So,
The following scores were obtained by 11 footballers in a goal shoot competition.
let me just check that door. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
All right.
11?
11. All right. So here we know that we are asked to find the modal score, right? So in finding the modal score here, what comes to mind when we think of the modal score?
Mode. So the mode talks about the most frequent value within a data set. So what about 5? How many 5s do we see?
No,
It's
but
the most
before you
frequent.
even, that's what I was wondering, why you just start picking out some numbers randomly.
Because sometimes, you just want to do that.
Yes, but you can't just pick a number randomly like
So
that.
the mode talks about the most frequent value, the most frequent piece of value. I'd like to call it piece of data.
All right.
So there are different scores being obtained. Which one are you seeing obtained several times?
All right.
Most often.
10, okay.
Let's use that. Most frequent.
All right. And you're saying, what about a 5? I think in looking at it, just
Eight
like
look,
this.
The 8 look like is it? 8 look like is 2.
Look, but is there something that we could do to even make it a little bit easier for
Well,
us
we
to
could
just
organize
look
the
at
data
it?
because it's a mess right now.
All right, so let's organize the data. So here goes. So we organize the data here. So in organizing the data here, is it a little bit easier now for you to identify the modal? So because right here you don't need to calculate anything whatsoever.
Yeah, guys, we need to just make an error. It's 12 footballers.
Oh,
it's 12.
yes, 12
right,
footballers.
because I'm here scanning through it and I'm seeing the 12 numbers. So it's 12 footballers in a goal shoot competition. All right, so the mode here, when we organize it, it's much easier to look at. So right away I see that there's 2 1s, 1 2, 3 3s, 1 5, 2 6, 1 7, and 2 8s. So the most frequent score would have been 3.
Yes, it is definitely 3. Are you seeing 11 there?
No, sir.
So 11 would have been out.
Yeah, because, I guess you could mistake the 1 and 1 beside itself and you think it's a large number.
Not good at all. Not good at all. But D would have definitely been out.
Oh, yes.
So when we're looking first, even when we arranged our numbers here, when we look, we realize that 11 is just not there.
Right.
So D would have been out.
Well, if you glance at the first set of data without organizing it, you may pick D now.
We still don't have 11. 11 is still not
well,
there.
yeah, D is out. You may pick 8.
So D is
C.
definitely there. So we could have said C,
Or
8.
D.
We could have said B, 6. We could have also said A, but now in looking at it, we realize that, hey, it's
It's
definitely
A. Right.
A.
So the best thing to do when you get a set of data, if it is possible, which most time you're not getting a lot of information, a lot of data, just organize them in either ascending order or descending order. It really makes it easier to look at and easier to pick out your modal value.
All right. So here goes. So we're finishing off with
So here you
our
go.
modal score there. And here we have a histogram. So the histogram shows the number of students going on a field trip. How many students will be going to the museum? So what information can be gathered from our histogram here.
So first it tells us the number of students at different age levels, because it does state on the x-axis age in years, and on the y-axis you'd have seen the number of students. So it's
right.
definitely telling you the age and how many students exist at that age. So all of these students are going to the museum. So let's calculate now. So the first bar would have been age 4, but that's not really important. The age is really not important here. It is really how many
Students, yes,
so
that's
it's
what we're trying
3
to figure
for the
out.
first
3,
bar,
right?
4 for the second bar,
All right.
2 for the third, and 5 for the bar that
fourth,
says 7
yes.
years old, and the fifth bar would have been 1.
So what we do with all those
Well,
values?
you're
we
going to
have
add them up. So you have 3 children there, so 3 4-year-olds,
Three,
4
four,
5-year-old, 2
plus
6-year-old, 5 7-year-old, and 1 8-year-old.
Right, so we are
You
going
add
to
them.
and when we add them, we arrive at
15 students. So your options, there you go.
B.
Now, if you did choose D, 85 students.
85,
87
87 students.
Wow.
That would have
You
been
know?
a lot of students.
Now, you could have gone 1, 2, 3, 4, 5.
Yes.
So A, you could have done that, but that's not understanding what the question is asking. 75 way out as well. I don't know how you get 75 still, you know. But, hey, you just have to understand what the graph says to you and how to extract the information. Pretty simple question.
Yes, it is pretty simple. And we're going to look at a simpler one here. So the pie chart above shows how a student used 10 hours per week for studying English, math, French, and geography. The amount of hours spent studying French is approximately, so we know that all 4 subjects,
Are
10
represented.
hours,
Yes.
right? So what can we know? We can look at our pie chart here and say, all right, math plus English is what?
5 hours is half of the time.
Great. So we know that math and English is 5 hours. So
Right.
in looking now at geography and French, we know that we would have had to have now 5 hours left
for those 2.
Yes, but we are given something else.
2 algebraic angles.
So what we're going to do here now?
So we can definitely say that 4x plus x would give us the total angle there, and that is equated to 5 hours.
yes,
So it's 5x equated to 5 hours, and we can definitely
simplify it.
simplify it. So
And in simplifying it, again, we're going to be dividing both sides
throw it by 5.
by 5, and we would now arrive at 1. But guess what? They asked us the amount of hours spent
For
studying
French.
French.
And
So French is what again?
4x.
So we know what geography is 1. How can we figure out French?
Simple, man. If geography get 1 hour out of the 5 or 4 left. So you want to study French for 4 hours. Or you could do it in an algebraic way
Can
and
just
multiply
multiply
4 by 1.
All right. So, okay.
So we're now beginning what? Probability?
Yes, we were looking at, we're still looking at multiple choice questions, but we looked at measurement, we looked at statistics, and now we're looking at probability.
Okay.
So let's get right into it. Of 120 students sitting an exam, 100 is expected to pass. The estimated probability that a randomly selected student is going to fail. How would you figure that one out?
All right. So they gave us the number of students that they expected to pass out of the total sitting the exam.
Right.
So I can definitely figure out how much they are estimating to fail. So it's 120 subtract that 100 gives me 20 students they're expected to fail. But 20 is, we already said that probability is from 0 to 1.
Yes.
So 20 can't work.
No.
So that is not it. All right. So it's, but you did say probability can be represented as a fraction.
Fraction, right.
So it's 20 out of the 120.
You're sure?
Yes, ma'am.
All right.
20, 1/20th.
All right. So let's see if you're right. Yes, you're definitely correct. But guess what?
What?
If we don't see 20, because if you realize just now I didn't give you your
No, you
options.
didn't give me any option.
So what if you don't see 20 out of 120? What's going to happen?
Well, all right. So since I can see that there are factors between 20 and 120, I can simplify that. So 20 factored right by itself gives me 1, and 120 divided by 20 gives me 6. 1 6.
All right.
Can I run with that?
So let's look at these both these answers and see which one pops up. So we have our 20 out of 120, and we also have our 1 6. So
Okay.
let's go.
So there are options. Hey, A.
Definitely. So we are definitely on a ball.
Yeah, man.
So let's take a look here now. So the table shows the distribution of the ages of 25 students. What is the probability that a student chosen at random is at least 13 years old?
You're right. I have that face puzzled. What least mean? At least 13 years old.
So that means the student can be 13 but must be older than 30. So can be 13 and older than 13.
So there must be at least 13.
Yes.
Okay.
So 13 is like the cutoff point.
So I can't use
go
the 12.
below. No, can't
Or
use
the
the 12,
11.
can't use the
Okay,
11.
great.
No.
So now then, let me see what the question is, because I was stuck at least. So I didn't even read I didn't even listen what you were saying. What is the probability that the student chosen at random is at least 13 years old? All right. So I have 13, 14, 15, 16. So I can select all of those students.
Right.
So, okay, so I now need to look at the number of students that have those ages. So we have 5 plus 4, that's 9. 9 plus 4, that's 13. Plus 3, that's 16.
All right.
So 16 out of, we need a total.
They gave you the total.
16 out of 25.
Right. Good job. So again, for those of us who would have missed it, here, if we did not pay attention to how many students we were given, it's 25.
So I would have gone and added,
Yes. So you could have gone to add, but guess what? They would have already given you. And you rightly did. This is at least 13 students, which is 16.
13 years old.
Yes, 13 years old. And our probability here is 16 out of 25.
Right.
So we are getting there, and our answer is D.
There you go. And 1625 is less than 1.
Yes, it is.
Yeah.
It is definitely less than 1. So we have a box here. So in a box, looks like a jar, there are 3 white, 4 red, and 2 blue marbles. What is the probability that a marble taken at random is not blue?
You see how them stay? And some people just see blue.
Right.
And say 2/9.
All right.
Because you're not looking at the knot.
And
so
you realize that's an answer there? Well, not the answer, but that's an option there.
Great. So not blue would have been white or red. And I can simply add 3 plus 4 is 7. So 7/9 would be not blue.
That is indeed correct. So here goes. Let's see if you are fully paying attention. So a bag contains 7 red sweets, 5 green sweets, and 8 blue sweets. What is the probability that the sweet is red or green?
Red or green, red or green. So they have red, green, and blue. So red or green. So it would be 7 plus 5. That's what?
12.
That's 12 out of, how many sweets I'm saying?
They did not tell you, so now you need to figure out.
So 12 plus 8 is 20. So that's what, 12 20th?
Yes.
Okay.
Good job. Good job. So here we are taking a look at a die now. So a fair die is rolled twice, right? Now, question for you.
What do you mean fair die though? It's balanced.
The die have 6 faces. Yes? It's fair.
Because people cheat with the dice, so they put one side heavier. So it's fair, it means that all the sides have the same probability of getting it, right?
All right. So what is the total possible outcomes then of when, because it's asking, what is the probability of obtaining in total at least 11?
So let's see what values would give us 11.
All right.
So the first die could drop on a 6.
6.
And the second would have to be 5.
All
so that would
right.
give us 11. It at least means that it can be greater than 11 too.
Yes.
Okay, so it could be 6 for one and 6 for the other.
Right.
Then the next time it could have been 5 first.
5.
And then 6 on the second throw.
So how many possible outcomes are these? How many?
That's 3.
So we have here, the outcomes here would have been,
so you have
possible outcomes would have been 3,
outcomes.
but hold on. The fair die is rolled how many times?
That's twice.
Twice. So when you roll the die once, right?
Yes.
Now we're going back to independent events. So when you roll a die, remember when it's independent, it doesn't have an impact on what comes next, which that is why they told us that the die is rolled twice.
Right.
So what would have been the total outcomes then when you roll the die once?
6.
6. Great. And what would have been, so the probability of rolling the die once would have been 6. What's the probability of rolling it a second time?
6 again.
6 again, right. So that would have now given us the total outcomes, which is 60. So it would have now been our possible outcomes 3 out
of
of
36
our 36
possible
outcomes.
outcomes.
Right?
Okay.
So this is our possible outcomes out of our total outcomes. So it's
Okay.
3 out of 36.
Okay.
Which is here. So we have to try and remember, which we would have learned earlier,
Yes.
about independent events and also dependent
Right.
events, because right here we're taking a look at independent events.
Okay.
What our last and final question for today, similar to the die one just now, 2 5-sided spinners, each marked with 1, 2, 3, 4, and 5,
Right.
are spun at the same time. What is the probability of obtaining the same number on both spinners? And again, the total possible outcomes would have been what? How many sides we have?
Well, 5.
5. So
it's
it would have been 5 times 5,
25.
25. And how many? So that would have been our total outcomes, yes.
Right.
And what would have been our possible now? So when you roll it, you can either get
One and one?
2, 3, 4, and 5, right?
So
it's the same.
5.
So it's 5.
5 possible times that you could get the same numbers. All right. So this is our final question. All right. So thank you very much, everyone, for staying tuned with us. It was a pleasure teaching you today. I hope you have a better understanding of how to approach measurement, statistics, and probability multiple choice question. Now remember, guys,
Wash your hands,
wear your mask,
sanitize, and keep your
your
distance.
distance.
Bye.